Math is understanding. Math relies on understanding to move forward. If you don't understand that 1 plus 1 equals 2, then how can you get to the point where you can understand that 2 plus 2 equals 4? And if you did not understand that 1 plus 1 equal 2, you simply just couldn't move forward. Unless someone has stated that it is true by way of proof. You could be able to take it as fact and deduce with logic that if 1 plus 1 equaled 2, 1 plus 2 would probably equal 3. And from there you could move further and further and further with math. Well, as it turns out, math has moved a lot further than simple addition, but it's still not totally understood. Usually, something's either true or false, and that's it. But there's one problem that, as far as we can tell, has another answer. Undecided. This is the continuum hypothesis. And without getting into it too deeply, the basic idea is this. We have a number line that runs to infinity in either directions. So you have 1, 2, 3, 4, 5, etc. And on the other side, we have minus 1, minus 2, minus 3, minus 4, etc., etc. These are all natural numbers. And let's call the infinity that goes off in either direction infinity set A, which is all of the natural numbers. 1, 2, 3, 4, minus 1, minus 2, minus 3. All those numbers, infinity set A. Now, when we look between 1 and 2, when we zoom in, we see there's a half in there. And we also see quarter, and we see thirds. And these numbers are called real numbers. And there's also an infinite number of these numbers just between 1 and 2. So let's call the sets between natural numbers infinity set B. And it is agreed that infinity set B is bigger than infinity set A. There are more numbers in infinity set B than there are in infinity set A. Now, the question is there an infinity set that is smaller than B but bigger than A? It's a tough question to answer. In fact, it's so hard that the only proofs and answers that we have is we can prove that we cannot prove it to be false, and we can prove that we cannot prove it to be true. Our understanding of math just isn't advanced enough. Because we can't properly comprehend infinities, we just can't get an answer either way. But what if a computer could comprehend infinities and actually answer the question for us? And just say, yes, there is an infinity between A and B. Well, then we'd have an answer. But how can we tell if the answer is right or wrong? Maybe we should get another computer to tell us. But then we go down this never-ending spiral of, but how do we know for sure? Well, maths is heading in that direction. We're looking at computers to solve problems that are so deep and complex that we can hardly understand them. And then take the information it spits out and go use it in another equation for deeper and more complex answers. But what's the value of an answer without the understanding? Well, with these answers, we can start to be able to do some pretty crazy things. Who knows? Maybe one day we'll meet aliens and the aliens will ask us, how the heck did you get all the way out here? And our answer will be, I don't know.